I was planning my next trek last night. As I was going through the various options, I saw some pictures of BYJUS, the place in the Himalayas where the river BYJUS originates. My very first Himalayan trek. I still remember my excitement as I stood at the base camp, hearing my trek guide tell us we're going to climb up 3,690 meters in the next 4 days. The adventurous side of me was anticipating the exhilaration I would feel standing up at that height. The nerdy side of me, I must admit, was wondering how my guide knew the peak was 3,690 meters high. He probably read it somewhere. But who actually measured it? And how? Did someone physically measure it as they trekked up to the peak? Where did they find such a long measuring tape? How did they ensure the measuring tape was straight rather than winding as their path was likely to? Furthermore, if the only way to measure its height is to physically run a measuring tape across it, how do we measure distances to stars and other heavenly bodies? We'll answer these questions and many more in today's session. We have a very interesting topic at hand today. One that has several real-life applications. One that you've already learned. All we're going to do in this session is apply what we already know to answer these questions. The topic I'm alluding to is trigonometry. That's what's going to give us all these answers. So as promised, let's see if we can actually measure the height of a peak. Let's say we have a mountain peak here. Or for simplicity, instead of the peak, let's start with a pole. Let's start with a pole. You know how to measure the height of a pole? You can, in the exact same way, measure the height of a peak as well. So let's say I have a long pole here and I need to measure its height. Now, for the sake of simplicity, I'm going to assume that I'm actually standing inside a hole of sorts and the ground is at my eye level. You'll soon realize why this is important. So the ground is at my eye level, so the base of the pole starts at my eye level and the pole goes on further up from there. Now we need to measure the height of this pole. How do we do that? I already gave you a portion of the answer. I told you that it was going to be trigonometry that we use to measure the height of this pole. But where's a triangle? Do we see a triangle anywhere here? Actually, we do see one side, right? The pole looks like a nice straight line, which is why I picked a pole instead of a mountain. That's a nice straight line. Where we need two more lines, right? Or two more sides to form the triangle. Now, if you join the pole to my eye, that could be the second side of the triangle. This is nothing but the distance on the ground, how far away I am from the pole, right? That's the second side. Now, imagine me looking up at the pole and imagine the ray of light that is touching the top end of the pole and reaching my eye. If you were to imagine that ray of light and you draw a line for it, call it my line of sight, that could be the third side of the triangle. That could be the hypotenuse of the third side of the triangle. Great, right? We have a triangle here. The height, one side, the vertical side of the triangle is our pole. The horizontal side is the distance between the base of the pole and my eye. And the third side is my line of sight. Perfect. So we have a triangle here, right? We have a triangle here. All we need to do is measure one side of this triangle. How do we go about measuring that side? The horizontal distance, if you see, can very easily be measured, right? I could just start at the base of the pole and walk up to here and measure it. It's a distance on the ground. Very simple to measure. So this distance we can measure.